this computer. All right, I believe we're recording now. We're going to pretend like we haven't already started. Here's our objectives: Pythagorean theorem and finding basic trig ratios. Awesome. What is a Pythagorean theorem? Someone said a squared plus b squared equals c squared, and we said that was on the right track, but not specific enough. And then who was talking just barely? What'd you say, person?
I said that it's like the legs of the right triangle equal the hypotenuse.
Good. So we're talking about we're differentiating between the legs versus a hypotenuse. And what is a hypotenuse?
It's the longest part of the triangle.
Good. Now, to be a little more specific here, what type of triangle are we using?
A right triangle.
Which means what?
The degree of the triangle is 90 degrees.
Awesome. Now, who's talking? I'm trying to like figure out who's talking.
Hashira.
Thanks, Hashira. I'm like looking for your name to pop up in yellow and it wasn't. There you are. All right, good job. Thanks, Hashira. So let me actually show you this video. We'll probably get a Grammarly ad, but we're going to watch this video and it's going to demonstrate the Pythagorean theorem. Give me a thumbs up, Anthony. Can you see this Grammarly ad? See? So predictable. Actually, I think I have it somewhere else. So I got my essay printed. Grammarly's the worst. Okay, this is going to demonstrate the Pythagorean theorem. And I want you guys, as we're watching this, how does this demonstrate the Pythagorean theorem? Wait for it. Not done yet. Okay, cool. Well, that's where I'm going to pause it. How did that demonstrate the Pythagorean theorem? Someone unmute yourself and tell me.
It showed that the two legs of the triangle equal the hypotenuse squared of the triangle.
Awesome. So the square, that's the important thing there. So if I build a square off of the legs, the sum of these two areas here, can you see my mouse, guys? Anthony, if I'm going back and forth, you can see that. All right. If I flip that over, it's the same as the hypotenuse squared. Or in other words, wait, wrong slideshow. In a right triangle, where A and B are the legs and C is a hypotenuse, the sum of the square of the legs, so A squared plus B squared, is equal to the hypotenuse squared. Thus, A squared plus B squared equals C squared. Now, someone might be like, hey, I said A squared plus B squared equals C squared from the beginning. Yes, but you have to set it up. First off, it has to be a right triangle. Second, A and B have to be the legs and C has to be the hypotenuse. And then you can say A squared plus B squared equals C squared. This is a guaranteed topic that will come up on the ACT. You'll definitely see at least one, if not multiple questions for this. And it's going to show up in this section too. We're doing a lot of solving triangles in this section, okay? Now, let me demonstrate how we're going to use this. And you've probably all seen this before, but what I'm going to do, let me get out my pen first. So first question I'm going to ask, is this a right triangle? And you would say yes. How do you know it's a right triangle, guys? Unmute and tell me.
It has the square in the corner.
Yeah, it has that little red square. That means 90 degrees, right? Great. So what I'm going to do is I'm going to start with my formula here. Hey, I said do a pen. Why aren't you cooperating? A squared plus B squared equals C squared. Now, what letter is always a hypotenuse?
C.
D.
Thanks, guys. So this is going to be C. So A and B, it doesn't matter which one I use. So I'm just going to say 3 squared plus 4 squared is equal to C squared. 3 squared is 9. 4 squared is 16. So that tells me if I add up their squared areas, it gives me 25. So that's what C squared is equal to, but we don't want just C squared. We want the square. We want just C. So how do we undo a square? We square root it, and that gives me 5. The length of the hypotenuse is 5. And this gives you a Pythagorean triple, which is called the 3, 4, 5. Guaranteed that you'll see a Pythagorean triple on the ACT. That's where if I know that one side is 3 and one side is 4 in a right triangle, what does the hypotenuse have to be? It's got to be 5. Okay. Or if I know the hypotenuse 5 and a leg is 3, then I know the other one's going to be 4. So we actually use this a lot in making what you'll see people do. Like, for example, I'm still a soccer coach, but back in the day where we had to paint our field, it was really important that we made sure we had a right angle. And so what we would do is we would take a piece of rope and stretch it 30 feet, do another rope 40 feet, and then do another rope 50 feet. And that made a right triangle. And we would use that to set our base for one corner of the field, basically. So anyway, pretty cool. That's how you use a Pythagorean theorem. Do you have any questions? I'm going to open it for 10 seconds for someone to ask a question before I go to the next example. 9, 10. All right, we're going to the next one. By the way, you guys can just write this down on paper, or I put some notes on Canvas, whatever you want to do. Wow, you already printed them. Good job, Anthony Ortiz. Look at you. Okay, we're going to go to this one. How is this one a little different? Well, now we're not solving for the hypotenuse. We're solving for a side, a leg. Okay. Now, it doesn't matter which letter I let that be, as long as it's A or B. Let's say this one's A. We'll call that one B, and we'll call that one C. So again, I'm going to start off with A squared plus B squared is equal to C squared. Don't know what A is, but we do know B is 12, and I do know that C is 13. So let's go through and let's just simplify that, okay? So 12 squared is 144. 13 squared is 169. And I want to solve for A. So I'm going to isolate it by subtracting 144 on both sides. And when I subtract 169 by 144, I get 25. So once again, I'm going to take the square root of that, and I get that A is 5. And this is, once again, another Pythagorean triple. I should have explained that better. A Pythagorean triple is when you have whole numbers that represent the legs and the hypotenuse of a right triangle. Okay. How are you feeling on that? Thumbs up? Are we okay with that? Cool. You are not always going to get perfect, nice whole numbers like this, but when you do, they are called Pythagorean triples. And here are some examples of those Pythagorean triples. Okay, the easiest is 3, 4, 5. We also saw 5, 12, 13, but there's also examples out there like 7, 24, 25, 8, 15, 17, 9, 40, 41. Those are Pythagorean triples. You can also double these. So if I did 3, 4, 5, it doubled, it would be 6, 8, 10, or 9, 12, 15, or 12, 16, 20. I don't really have any of these memorized except 3, 4, 5. But on the ACT, I would recommend you at least have this memorized, because that will save you time. If you're working with a 3, 4, 5 triangle or a 6, 8, 10, you can easily figure out what the other side is without having to do calculations. But let's do a quick example where we don't have perfect triples, perfect numbers. We're going to do this, and then we'll move on to trig ratios, okay? So I need someone to volunteer for this. For one to explain the left one to do the right one, and then we'll walk through to see how we get the answer here. By the way, if we all just sit here in silence, it's going to take longer. So if you want to get out of this lesson sooner, you need to participate. So who wants to volunteer for this first one to walk us through it?
I will.
You go, Keegan. Go through it.
Okay, so you'd start with a squared plus b squared equals c squared. And then you would label the sides. So 12 yards could be A, 13 yards is B, and X is the hypotenuse, so that's C. So then you'd write that in. So 12 squared plus 13 squared equals C squared. 12 squared equals 144, and then plus 169 equals C squared. And then you'd add that together, and I don't know what that is. 313, yeah.
Is that right? Okay, I'm like, okay.
So 313 equals C squared, and then you'd square root 313, which is 17.69.
Cool. We'll just go to one decimal, so we'll call that 7.
Okay.
And there you go. Nice job, Keegan. You guys okay with that? You will need a calculator to do the square roots because you can't do that in your head. At least I can't. Awesome. So that would be an example of finding the missing hypotenuse using the Pythagorean theorem when it doesn't work out so neat. It's not just perfect squares. Awesome. Okay, I need one more volunteer. Let's do this other one. By the way, so Anthony, I need you to help me here. So I've got a window of you guys. Can you see my window of you guys? Like, can you see your face on the screen? Thumbs up or thumbs down? Like if I'm moving it in a circle right now, can you see me moving your face in a circle?
I only see you, me, and then the example.
But it's not moving in a circle right now, right? You control your own viewer.
Yeah.
Okay, cool. Just making sure. Okay, I need someone else to do this next one. Explain it just like what Keegan did, but this time we're finding a missing leg.
I can do it.
All right, Johnny, you got it.
Okay, so you start it with a squared plus b squared equals c squared again. Then you'll substitute 4 squared for one of the legs and 14 squared for c.
I don't really mind the order. What if we just do like that? Is that okay?
Yeah.
Awesome. Keep on going.
And then you'd then you do the exponent, so it'd be x squared plus 16 equals 196. And then you subtract 16 on both sides, and then it becomes x squared equals 180. And then you square root both sides, and I got 13.4.
Awesome, Johnny. Looks great. Does anyone have questions on either of these two? If you do, you've got 10 seconds to ask it, or we are going to move on. All right, good job. So then let me just show you on Canvas what you're going to do next, okay? So you guys can see my Canvas here, right? I'm pulling it up, it's loading, but you guys can see that, right? Anthony, give me a thumbs up, you can see it, cool. So when you go onto Canvas, make sure you go into the new semester. So it'll be for the spring semester for our class. And what you're going to see is there's this new module called the Chapter 4 Trigonometry module. Let me show you what it looks like for you guys. There you go. So in this top one, this is going to be today's lesson, but these are going to be the practices you're going to do. So we've covered Pythagorean Theorem. What you guys are going to do is click on this, and it's going to have like 5 real basic Pythagorean Theorem questions, okay? And so you're going to go into it, and you're going to, for example, here's one side, here's the other side. You solve for that, round to the nearest tenth. You put in the answer, and then you can check you did it right. You got 5 questions like that. Now, I think I actually ended too early. I think I have one more. No, oh, nope, I didn't. We're done there. Okay. There is going to be a story problem. Don't get scared by the story problem. It's the same as like doing it without a story problem. Okay. It's pretty basic. So you guys don't start that yet. We're going to go over trig ratios real quick. It shouldn't take very long, and then we'll move on from there. Okay. Now, please, if you have a question, just interrupt me. Most of you aren't showing me your beautiful faces, so I can't see a hand or a confused look on your face. So you have to just interrupt me, okay? Now, I remember growing up, hearing my older siblings talk about trigonometry. Trigonometry, it sounds like a scary word, but it's actually pretty basic. It's just talking about properties of triangles. So when we're talking about trigonometry, it's just properties of triangles. And if we're doing trigonometric ratios, a ratio is basically just a fraction. So that's a fraction of 2 sides in a right triangle. Now, when we're looking at a right triangle, there's going to be 3 vocabulary words we're going to use. We're going to have hypotenuse, we're going to have the adjacent side, and the opposite side. Now, that's going to be based on this guy's perspective. So what is the name of this guy? Someone unmute and shout out, what is the name of that guy? Anybody know it's a Greek letter?
Theta.
Good job, random person. It is theta. I don't know who said that, but good job. It is theta. If you're like, how do you even spell that? I'm sorry. Drawing with my mouse is not pretty. So there is a theta. Yes, that's how you spell it. Now, when we're looking at this angle's perspective, we're going to label each side as opposite, adjacent, and hypotenuse. Now, hypotenuse is always going to be the longest side, which is always across from the right angle. Hypotenuse. It's always across. Now, adjacent is just a fancy word that means next to. Next to. So what side is next to theta? Oh, it's this side right here. So we call that the adjacent side. Okay. An opposite means across. So I'm going to say what side length is across from theta, and that would be this one. Okay. Now, you might think this is really basic, but if you don't understand this, you're going to fail this chapter. Like, not to be rude, but that's just the truth of it, okay? So when I'm looking at this triangle down here with A and B, here's theta. And what I'm going to do is try to label what is A and B in their perspective. I think C's down here actually, but let's label all 3 of them. So A is the longest side. It's across from our right angle. So we label that as our hypotenuse, which I'm just only going to use the first 3 letters. B is next to it, so that is my adjacent side. And then C, it kind of got moved and didn't get copied, but there's C. It's across from theta, so we call that the opposite side. Okay, that's how I'm going to label my sides opposite, adjacent, hypotenuse. Now we're going to do the same thing over here with this triangle, but I want you guys to label those. I'll give you 10 seconds, and then I'm going to ask one of you to tell me the answers. But label EFD as opposite, adjacent, and hypotenuse. Go. All right, so now I need someone to speak up and tell me from theta's perspective here, which side is going to be opposite, which is adjacent, and which is hypotenuse.
Side D is the hypotenuse. Side F is opposite, and side E is adjacent.
Awesome, thanks, Keegan. So there we go. That's how you label opposite, adjacent, hypotenuse. It depends on where theta is, okay? Now, let me do this real quick here. It depends on which angle you're looking at. So for example here, if I'm looking from P's perspective, then I would label this as hypotenuse. This would be across, this is opposite. And then right here, this is adjacent because it's next to P. However, if I switch angles and I look from R's perspective, the hypotenuse is still a hypotenuse, but notice now this side that was opposite of P is going to be right next to R. So this is my adjacent side, and this is my opposite side. So they switch. So it's really important you know which angle we're looking from. Now we're going to create trig ratios, which is where we're going to look at a ratio or a fraction of two of these sides. And we're going to have three fancy names we're going to use. We're going to have sine, cosine, and tangent. We're going to shorten that to be just sine, cosine, tangent. If you call it sin, I will slap you. Even on a Zoom lesson, I will slap you. Okay, I'll reach through your computer. Sine, thank you. All right, now sine is going to use the sides opposite over the hypotenuse. So I'm just going to take the side lengths and do opposite over hypotenuse, that's sine. Cosine is going to do my adjacent over hypotenuse, and my tangent is going to do opposite over adjacent, okay? Now, it's sometimes hard for people to remember which sides go with what, so we've come up with a million different ways to do that. Let's actually just do an example, and then I'll get to the fun ways we can remember that, okay? So if I'm doing sine, first what I'm going to do first, let's look, I'm going from B's perspective. So I'm going to start off by labeling my opposite adjacent hypotenuse. Hypotenuse is the longest, 3 is next to angle B, so that's our adjacent, and 4 is across from the angle, so that's my opposite. So what I'm going to do is say sine is opposite over hypotenuse. The opposite is 4, and the hypotenuse is 5. So the sine of B is 4 over 5. That's it. Cosine is going to be adjacent over hypotenuse. In this case, the adjacent is 3 and the hypotenuse is 5. So that's going to be 3 over 5. And lastly, tangent is going to be opposite over adjacent. So I look at opposite over adjacent, and that is 4 over 3. Okay, that's an example. Now, how do you remember this? When you guys were first taught this, were you taught any fun, crazy ways to remember this, or were you just taught SOHCAHTOA? Like in 9th grade, my teacher taught me the story, some old horse caught a horse taking oats away. And I've heard a lot of other crazy versions. I know Miss Allen teaches some old hippie caught a hippie tripping on acid. But that's a different way to remember it. I usually just go with SOHCAHTOA. Now, I'm going to show you this video because I think it's a good video and I think you guys will appreciate it. This is just going to help reinforce SOHCAHTOA, okay? Shoot. No, was it not that one? Oh, I guess I don't have it yet. Let's just click that link then. It's a short video, but it will change your life forever, okay? We'll probably have to go through a Grammarly ad. No, I think this is going to be a TripAdvisor ad. Darn these ads. New. Anthony, can you hear it?
Kind of quiet, but yeah.
Opposite hypotenuse sine. Opposite hypotenuse sine. Opposite hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse tangent. Opposite adjacent tangent. Opposite adjacent tangent. Opposite adjacent long sides of hypotenuse. And the other two sides depend on which angle you're focusing on. Pick one angle and look. There's one side that's the opposite. You can clearly see that there's also an adjacent side. Sine. Opposite hypotenuse sine. Opposite hypotenuse sine. Opposite hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse cosine. Adjacent hypotenuse tangent. Opposite adjacent tangent. Opposite adjacent tangent. Opposite adjacent.
Every. All right. I can't see you guys, but I'm sure you were dancing along to that. It's just so catchy. Okay, so let's do a couple examples and we'll be done. So, for example, let's say here's my triangle. Notice it's a right triangle. It has to be a right triangle. I want to find the sine, cosine, and tangent from angle A's perspective. Okay, so the first thing I'm going to do is I'm going to circle A and then label my sides as opposite, adjacent, and hypotenuse. Okay, so hypotenuse is always the longest side and it's across from the right angle. The adjacent side is next to our angle, and then the opposite is across. So then I would say sine. We just listened to that song. Sine is which two sides? Sine, opposite hypotenuse, sine. So opposite hypotenuse, that's 21 over 35. Oh, look, this is reduced by 7. That becomes 3/5. Cool. That's a 1, by the way. Okay, now we go to cosine. Cosine, adjacent hypotenuse, cosine. So adjacent is 28 over 35, which again, that's divisible by 7. That becomes 4/5. Lastly, tangent, opposite adjacent, tangent, opposite adjacent, tangent. So opposite adjacent is 21 over 28, which reduces by 7 to 3/4. That's how you find trig ratios, okay? I'm going to give you guys a 20-second head start. I want you to find the sine, cosine, and tangent of A. You're going to start by labeling the opposite, adjacent, and hypotenuse. Then you're going to find sine, cosine, tangent by using SOHCAHTOA. Maybe I'll count to 30 and then I'll ask for a volunteer. Go. All right, I need a volunteer unmute. Tell me how you labeled your sides and how you got sine, cosine, and tangent of angle A. If you don't volunteer, I will just look at my list here and just call someone out. All right, we're going to do it then. We're going to go to Natalie Ocampo. You're new to this class. You just transferred from 3B. So what a great opportunity for you to introduce yourself and solve a problem for us. Yeah, Natalie, you there?
Yeah, I'm here.
Awesome. Can you show us how to do this?
Sure. Okay, so the opposite side to A is 12, and then the adjacent is 5, so the hypotenuse is 13. So for sine, it would be 12 over 13. And then for cosine, it would be adjacent over hypotenuse would be 5 over 13. And then for tangent, it would be 12 over 13.
Hold on, not over 13 though.
Sorry.
So for tangent, what sides do we use? Natalie, where'd you go?
Oh, sorry. I didn't realize I was muted. Oh, it would be 12 over 5.
There we
right?
go. Thank you, Natalie. I put her on the hot seat, but she did great. Okay, so there you go. That's how you do SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. Okay, now you're going to have another online assignment for this too. That's super easy. This is like what most of the problems look like. It just says, hey, what trig ratio can we use for this? So if I'm looking right here, there's theta. How would I label A and B? Well, A is a hypotenuse and B is my adjacent side. So what trig ratio uses adjacent and hypotenuse? You go through SOHCAHTOA and you'd think, oh, it would be cosine, because cosine of theta is your adjacent over hypotenuse, which in this case would be B over A. Okay, let's do one more together and then you can do the last one on your own. I'm going to look at this other one here and say, okay, here's theta, and I have my hypotenuse and my opposite. Someone unmute and shout out which trig ratio uses hypotenuse and opposite.
Sine.
Good job. I had like 4 or 5 of you guys. Jinx. Okay, so sine of theta is going to be opposite over hypotenuse, which in this case is opposite is E over hypotenuse D. So I'm going to put that as E over D. And then last but not least, let's just have someone do this whole problem for me. All right, I'm going to just call him out. Parker J, this one's you. How do you do it?
Tan is opposite over adjacent, so it'd be G over F.
Tangent of theta is G over F. Thanks, Parker. And that is a wrap. That's all we're going to do for today. Pretty easy stuff, right? So what you guys are going to then do, or now do, is if you go on to Canvas, beneath where we saw the Pythagorean Theorem assignment, you're going to see one on trig ratios. And this is how complicated it gets, is just for you guys to use SOHCAHTOA, and that's it. You're not solving for sides or angles yet. That's going to be actually what we do on Thursday. So those are your 2 practices. You're just going to do those, and then you're done for the day. Cool beans? Do you guys have any questions? If you have a question, unmute and ask me. All right, so then I think what the plan is from here is I'm going to end this call. If you do have a question you were too shy to ask, you can just stick around. But you're going to sign off Zoom but work on this Canvas assignment and just get it done, okay? Because it'll literally, you'll be done in like 20 minutes or so. It's pretty easy. Then you're going to log in on Thursday. For some reason, my Zoom link from yesterday was different from the one I sent out today. So just plan on me emailing you a link right before class, and that'll be your link, unless I figure something else out, okay? All right, well then you guys are free to go. So thank you for tuning in this fine morning. You guys are awesome. I will see you again virtually Thursday morning. If you have questions, stick around, you can ask, but if not, we'll see you then. All right. right, let's go to